Okay, so let's take a look at this question. It says the reaction of X plus X sub 3 gives 2 moles of X sub 2. And it says it's shown to have an activation energy of 25 kilojoules per mole, while the enthalpy of reaction, so the change in energy of the reaction, is negative 388 kilojoules per mole. It asks, what is the activation energy of the reverse reaction? So if I have two X sub 2's going in the reverse direction and becoming an X and an X sub 3, what would be the activation energy of that reaction? Okay, so to answer this question, what we need to do is we need to draw one of those diagrams where I plot on the y-axis energy, and the units for that we'll say is kilojoules per mole. And then on the x-axis, we're going to call that what we have called the reaction progress. Reaction progress. Okay. So one thing I need to do is to mark off the energy levels of my reactants and products. So let's say that line represents the energy level of my reactants, X plus X sub 3. And so now I want to do the same thing. I want to draw a line for my products. A line that represents the energy level of my products. Well, I'm told that the energy change, when this reaction occurs, that energy change is negative. It's a negative 388 kilojoules per mole. So the energy drops. So I'm going to draw that line lower than the line I have for my reactants. So that line represents the 2x sub 2. So that's the energy level of my products. This is the energy level of my reactants. And I know that in order for my reactants to become products, they have to overcome some energy barrier. They have to get over a hump, right? Okay? So they don't just automatically go from this energy level down to this energy level. They have to overcome an energy barrier in order to do that. And we're told the value of that energy barrier. It's 25 kilojoules per mole. Okay, so that difference between the energy level that they're at currently and the peak of that hump is 25 kilojoules per mole. Now again, I underline that to tell you that this is one of those problems where that number is going to change. You might have 15, you might have 37. This is the number that was given to me when I generated the problem set. Every individual might get a slightly different number there, but this method, the method of solving this is still the same. Okay, so I know that difference is 25 kilojoules. And I already said that this difference right here, okay, the difference between my reactants and my products is a negative 388 kilojoules per mole. Right? So if it asks me what's the activation energy, what's that energy barrier for going in the reverse direction. So if I want to take these guys and make them back into these guys, think about what the energy barrier is going to be. It's going to be this distance right here. It's got to go from this energy up to this energy. Okay? So quantitatively, what is that going to be? Well, in order for it to get just to this dashed line, we know it had to increase by 388 because that difference is 388. But then it had to go another 25 higher in order to overcome that energy barrier right there from the opposite direction. So the activation energy going in the reverse direction is a lot bigger than the activation energy going in the forward direction. So the answer to this question is simply 388 plus 25, okay, kilojoules per mole, which is equal to 413 kilojoules per mole.